Okay, so where that last video ended was I was attempting to find the time for the, sorry, let me adjust this, for the sound. So delta D over the V av, so 34 meters divided by 340 meters per second. All right? And then when we do this, still trying to get it clear, but maybe it's my glasses and I'm sitting too close. So we'll get a time for the sound to be, what is it, 0.1 of a second. Okay? And then the other piece we know is that it's going to take Millie a fraction of a second to process what's going on after Willie yells to her. And it says that she needs 0.4 of a second to respond. So now the question becomes, what do you do with these 3 times? So we found the 3 times, but what do you do with them? Well, this is the time altogether that we have to take, like that she needs, like 0.1 of a second for the sound to get to her and 0.4 of a second for her to respond. This is the time it's going to take for the pot to hit her on the head. And the question is, what is the minimum height of the pot above the ground at the instant Willie shouts his warning so she can get out of the way in time? In other words, the pot's going to fall, and he wants to yell at the very last instant possible so she can just miss getting hit. So it has to be a time less than the full time it takes to fall. How much less? Well, there's 0.5 seconds that she needs. So we're going to take 0.5 seconds off this time. So we're going to get 2.13 seconds. And then with this, we're going to find, so how far does the pot fall before he yells to her? So we're going to do delta D is equal to VI delta T 1/2, whoops, off the screen. Can't balance it out like that. 1/2 A delta T squared. This goes to 0 again. So delta D is equal to 1/2 the 9.81 meters per second squared. And this time the time is 2.13 seconds. And you're going to square that. And you're going to find how far does the pot fall before he has to yell to her. And so when you do that, you get 22.272 meters, I believe. Okay? But that's not the final answer, because it says what's the minimum possible height of the pot above the ground. So what we just found was how far did the pot fall down, but the question wants to know how far above the ground is it. So we have to go back to this 22.272 meters and take it away from the 35. And so the final answer will be 35 meters minus this 22.272 meters. And so in the end, the final answer is 12.728 meters. So that's how far above the ground it has to be for him to yell for her to get out of the way in time. Okay, so those were the 3 that I had asked you to definitely do last night. The other one I'd asked you to look at was this ball, was number 6. A ball is thrown straight up from the roof of a building. A second ball is dropped 1 second later. It says you can ignore air resistance, and it wants you to find the height of the building. If the height of the building is 20 meters, what must be the initial speed? Now, you can try this one. Some of you should be able to get all of it. All of you should be able to get at least the first part of it. Okay, so set up the 2 balls, and maybe I'll just tell you the first little piece that usually messes people up. And I just figure out where my paper is and where which part of the paper the camera is acting on. I have it blown up so much I can't align it. There we go. So you're dropping one ball, and you're throwing the other ball up in the air, and it's coming back down. They're both going to get to the ground at some point, and so both of their delta Ds are the same. Remember, delta D change in. So they're both starting from the same height. They're both ending up at the same height. You don't worry about what this one's doing up here, because in the end the change is the same. So people usually waste a lot of time trying to figure out how far up does this one go. It doesn't matter. Delta, change in, and it tells you the building is 20 meters. So for both of them, the delta D is negative 20 meters. Okay, so try number 6 today, and that should help you do it. All right, the other piece that I would like to talk to you about is vectors. Okay, back in grade 11, you learned about adding vectors. Okay, I think I have to turn the camera around. All right, and then I can expand it because it was like, okay, so adding vectors. And if you remember from grade 11, there were 3 cases. Case 1 is if the 2 vectors are going in the same direction. So if you have a 40 Newton force going east, and you have a 30 Newton force also going east, you line them up so they're head to tail, and then the resultant starts at the tail of the first, goes to the tail of the second, you add them, 70 newtons, you keep the direction east. Remember, we called this case 1 last year. Okay? Case 2, and so it's same direction, add them, keep the direction. Case 2, opposite directions. And these are really common sense. If they're going in opposite directions, my 40 newtons is still going east, but this time my 30 newtons is going west. The rule is you still line them head to tail, and then the resultant starts where the first one started and ends where the last one ends. So my resultant is right here. And how do you get it? You subtract them and keep the direction of the larger. So this is going to be 10 newtons east, since the larger one was east. And then the next case, case 3, was if they were acting at right angles to each other. So I still have my 40 newtons east, and this time my 30 newtons is north. Right, and that was when, and so the resultant starts where the first one started, ends where the last one ended, so it'd be right here, and it's the hypotenuse, and I happen to pick a 3, 4, 5 triangle, so square them, add them together, take the square root, and get 50 newtons, but then you also need to find the angle, and so for the angle you would do tan theta, which would be equal to 30 newtons over 40 newtons, inverse tan of 0.75, 36.87 degrees. My red pen is pretty weak there. And so the answer would be 50 newtons going east first, and then turning and going north. So to be 50 newtons, 36.875 degrees north. Remember that? Okay, so that's at the right angles to each other. And then the last case was any other angle. So the first case, the angle is 0 degrees because they're going in the same direction. The second case, the angle is 180 degrees because they're going in the opposite direction. In this case, the angle is 90 degrees, right angles. In this case, any other angle other than those 3. So if my 40 newtons was going this way, and now my 30 is going up like this. Okay, so my resultant would be here. And I'd have to tell you this angle here, and since we just used 36.87, I'll use it again. So that angle's there. And if you remember from this, there's 2 different ways we could do this. One way is to break this guy down into its components. Remember that?